everybody, Shane from Norman S. Wright. I realized that last week I discussed dual duct boxes, but I haven't done a video on what is a dual duct box, so let's talk about that this week. Let's get started. Dual duct boxes aren't as popular as single duct and fan boxes, but you will run into them every now and then. Like all boxes, dual duct box has a discharge that is ducted to the diffusers or grills in the space. The difference is that the dual duct box has two supply inlets, ducted to the supply air system. One inlet is ducted to cold air and the other is ducted to hot air. You might also see some dual duct boxes that have a cold air and an outside air inlet for ventilation. Like a single duct box, each inlet has a damper to control the amount of airflow in the space. Instead of having a hot water or electric reheat coil, like a single duct or fan box might have, the dual duct box has ducted hot supply air. One benefit for supplying hot air instead of using reheat coils is that you can filter the supply air at the air handler. So for instance, a hospital might want to provide filtered hot supply air instead of pulling plenum air from the space like you would with a fan box. Okay, let's move this over. There are actually two types of dual duct boxes. The first is a non-mixing dual duct box. This is basically two single duct boxes strapped together. The discharge to the unit would be ducted to the space. Here's the challenge with non-mixing boxes though. Because the hot and cold air streams are not mixed in the box, you could have cold air going down one side of the ductwork and hot air going down the other side of the ductwork if both of the dampers were open. So if I draw in some diffusers here, say that the diffusers are connected to this ductwork a couple feet down the box. This one could get only cold air while the other one gets only hot air. For this reason, non-mixing dual duct boxes often only have cold air or hot air coming at any given time. So let's delete this hot air damper and now close it. So in cooling, the damper of the hot duct would be closed and the cold damper would modulate to maintain comfort. And then in heating, the reverse would happen where the damper of the cold duct would close and the hot air damper would modulate. It's also important to note that when you're switching between heating and cooling modes, there can be a moment when both dampers are closed and no air is coming into the box, and so no air is going into the space. Now let's make room again. The other type of dual duct box is a mixing dual duct box. As its name implies, the box mixes the hot and cold air streams. Just like all dual duct boxes, we have a discharge and two inlets, but inside the box there's an area for air streams to mix, typically with a mixing baffle to help the air get well mixed. The mixing baffle forces the two air streams together so that they can mix well before going out to the discharge and then into the space. So now we have two diffusers in the space. They are both getting the same blended temperature air. We describe how well a dual duct box mixes as its mixing ratio. A 1:10 mixing box, the typical mixing ratio, has no more than 1 degree of temperature differential 4 feet off the discharge for every 10 degrees of supply air difference. So let's move this over one more time and look at this with some numbers. So for 1:10 mixing, let's say your cold air is 55 degrees and your hot air is 95 degrees. And let's add 4 feet of ductwork. So 95 minus 55 is 40 degrees. So if I were to take a traverse of temperatures at 4 feet from the discharge, you would have no more than 4 degrees variation in a 1:10 mixing box. A high mixing box is considered 1:20 mixing. So again, let's draw a box in and let's have 55 degree cold air and 95 degree hot air again, and 4 feet of ductwork. Again, our cold air is 55 degrees and our hot air is 95 degrees. This is still a 40 degrees difference, but now 1:20 mixing means that we have no more than 1 degree of variation per 20 degrees differential. So if we took a traverse of temperature readings at 4 feet from the discharge, we'd have no more than 2 degrees variation in that temperature. The higher the mixing, the more consistent the temperature from the box. But there is a trade-off. High mixing boxes have more baffling inside to ensure the higher levels of mixing, so they cost more and they can also have higher sound and higher pressure drop. But luckily most applications are fine with 1:10 mixing. Let's bring all this back on screen. So that's how dual duct boxes work. Don't forget to like and subscribe to our YouTube channel. Thanks for watching.